Hi, this presentation continues the series on multiple regression and focuses on the standardized regression equation in multiple regression. The standardized regression equation in multiple regression is expanded to include all predictors in the model. As before, z, y hat are all the predicted standard scores on y based upon various combinations of standard scores on the predictors. And consistent with bivariate regression, there is no constant in the standardized formula because the regression plane passes through the origin of the graph. The standardized regression coefficient in bivariate regression changes its name to the standardized partial regression coefficient in multiple regression. As just discussed in the presentation on the regression line in multiple regression, the value of beta depends on the size of the unique contribution its predictor makes to predicting variance in y after the effect of the other predictors in the model are partial or controlled. That means that areas in y that are redundantly predicted by more than one predicted are not considered in determining the value of beta. Beta is also the change in the predicted standard score on y when the standard score on its predictor increases by one z-score and when the other predictors are held constant. A negative beta indicates an inverse relationship between the predictor and the criterion, such that scores on the predictor increase, scores on the criterion go down. So if the predictor with a negative standardized partial regression coefficient increased one z-score, then the predicted z-score on y would decrease by the value equal to beta. Finally, beta no longer equals the bivariate correlation between the predictor and the criterion. This is because we only consider the unique effect of x on y in computing the partial regression coefficient in multiple regression.